The expression for the discharge current is, so a capacitor of 5 microfarad is being fully charged initially to 10 volt, is connected to a resistance of 10 kilo ohm and is allowed to discharge through it. The expression for the discharge current is, so a capacitor 5 microfarad being fully charged to 10 volt means initial charge on the capacitor is 10 volt and it is a 5 microfarad value. It is connected to a resistance of 10 kilo ohm at t is equal to 0 and is allowed to discharge. The expression for discharge current, this IT we need to calculate. Let us convert the given circuit into Laplace domain. So we can write 1 upon Cs. 1 upon Cs, so 1 upon 5 into 10 to the power minus 6. So it is 10 to the power 6 upon 5s battery. V0 upon S. V0 is 10 upon S. And current. This current is 10 to resistance 10 to the power 4, and suppose the current is IS. Now IS can be calculated as Vs 10 upon S divided by 10 to the power 4 plus 10 to the power 6 upon 5s. If we take 10 to the power 4 common, 10 by s, 10 to the power 4 is common, then 1 plus 100 by 5s. This is 20 by 5s, 20 by s. So IS can be written as 10 upon s divided by 10 to the power 4 into s plus 20 by s. S cancel out and this 10 cancel out. So it is 10 to the power minus 3 upon s plus 20. If we take inverse Laplace transform, then IT is equal to 10 to the power minus 3 e to the power. So we will have current which is equal to e to the power minus 20 TUT milliampere, which is given in option D. So right choice for answer is.
Open loop transfer function of a system is k s plus 1 s plus 2 upon s plus 3 s plus 4. The question is to find, for k is equals to 10, the closed loop poles of the system will be of what nature? To find the nature of the closed loop pole, one has to obtain the root locus of the system. The root locus of the system can be obtained to be this way. This is the root locus of the system. For any value of k from 0 to infinity, the roots of the characteristic equation called closed loop pole are found to be real and unequal. They are real but unequal. So answer to the question is.
In the next question, we have to find out Fourier series representation of signal ft. Now, first of all, by looking at this signal, we will draw another signal which would have 0 DC value. So we will draw a new signal xt with 0 DC, and if we will draw this signal, then it will look like this. This signal will look like this, and amplitudes will be +1 and -1 with same time instant. This time instant is 0 and this time instant is 4 and this time instant will be -4. Therefore, time period of given signal is 8. Time period of the signal which I have drawn is also 8. And if we will check, then this signal xt will satisfy half wave symmetricity, and the given signal is odd also. Now, as we know, if signal is odd half-wave symmetric, then it will contain sine terms with odd harmonics. Now, if we are going to write expansion of xt, then we will write down in this way. Xt will contain sine terms with odd harmonics. Sine terms with odd harmonics. Now we already know the expansion of signal xt, so we can write down the expansion of ft also. We can relate signal ft with drawn signal xt in this way: 1 plus x of t. Since these two signals are related with DC shifting or amplitude shifting, so they will have the same harmonic content. The only difference will be the value of DC. In case of xt, DC value is 0. In case of ft, DC value is 1. And it will have the same expansion, or it will have the same harmonic whatever xt is getting. So we can write down in this way. For 1 we can write down DC, and expansion of xt contains sine terms with odd harmonics. Sine terms with odd harmonics. Therefore, expansion of given signal ft contains DC term and sine terms with odd harmonics. If we will look at all four options, then option D will satisfy this result.
Question number 5. In this, he is saying in certain material, frequency is 100 gigahertz. So 10 power 9 giga means the magnitude of conduction current density and displacement current density are equal. He is saying mod JCS is equal to mod JDS. If the medium has conductivity sigma 10 1 by ohm meter, and find relative permittivity, find epsilon r. Is saying now JCS is sigma mod ES and omega epsilon mod ES. Now mod ES cancel. Omega is 2 pi f epsilon naught epsilon r. From this, epsilon r is equal to sigma by 2 pi f epsilon naught. So sigma value given is 10, 2 pi, frequency is 10 power 11 and 1 by 36 pi 10 to the power minus 9. From this, epsilon r value is 1.8 and option is C.
This question is based on a diode circuit in which we are supposed to calculate how much is the output voltage. And as you can see from the connections, we have germanium diode and silicon diode connected in parallel. And from observation we can say that out of this germanium and silicon, because germanium has a less cut-in voltage of 0.2 volt, a germanium diode will operate in forward bias and 0.2 volt will appear across the germanium diode, and because of that silicon diode cannot conduct. For silicon diode to conduct, it needs 0.7 volt across it, but because these diodes are in parallel, only germanium diode will be able to conduct. Therefore, we can consider germanium diode as on, and across germanium diode we can indicate a voltage drop of 0.2 volt, whereas silicon diode will remain off, so I replace it by open circuit. Whenever two diodes are in parallel in this way, then a diode having less cut-in voltage will be in forward bias and the other diode will be off. Next, if you look at the remaining two diodes, they are in reverse bias condition. So let me initially assume them as open circuit. And then what we can observe is out of 12 volt, 0.2 volt will drop here, and remaining voltage, that is 12 minus 0.2, 11.8 will appear at this node. And if you notice the voltage difference from this node, or you can indicate 11 point even here, because diodes, these two diodes are assumed as off here, so same 11.2 you can view even at this node. And if you notice, the potential difference from this node to this node is 11.8 minus 2, that is 9.8 volt. That means 9.8 will be present across both these diodes, and that reverse bias of 9.8 is less than the breakdown voltage of both the diodes. And therefore you can also say that none of these diodes will be in breakdown, and therefore both these diodes will act like open circuit only. And therefore the conclusion here is, out of all the diodes, only this germanium diode is in forward bias. It will conduct, it will have a drop of 0.2 volt. This silicon diode is off, and these two diodes are also in reverse bias and in off condition. And therefore for this question the answer is output voltage is equal to 11.8 volt. And if you look at the options, you will find it as option B. The correct answer for this question is,
we are having here a question as essential hazard is defined as. So basically essential hazard is along with two or more paths, the delay associated with two or more paths, the delays associated with the two or more paths origin from the same source, from the same point. It is defined as essential hazard. So based on the given options, if you look, the answer is option D. So in the option D it is mentioned as the unique delays along two or more paths that originates from the same input, that is essential hazard.
In this question, a 10 pole lap wound DC armature has a total of 200 conductors. So pole is, number of pole is 10, lap connected means A is equal to P is equal to 10, parallel path will be 10, and Z, the total number of conductors are 200, each with a current carrying capacity of 10 ampere. So current carrying capacity of each conductor is 10 ampere. Now we have to connect this 200 conductor in 10 parallel paths. So the number of conductor will be total, it is 20 conductor per parallel path, and 10 parallel paths are there. So this is 1, 2, something like that. This is 20. This is the winding circuit diagram, we can say that. Here it is 10, parallel paths are 10, and the number of conductors are 20. So total conductor will be 200. Now it is asked to calculate the power rating of the DC machine. Then current carrying capacity is 10 ampere, and the average induced EMF per conductor is 10 volt. Here the induced EMF is 10 volt. So EMF per parallel path will be, in one conductor 10 volt is there are 20 conductors, so 20 into 10, that is 200 volt is the induced EMF per parallel path. And the current is, in one parallel path current is 10 ampere, there are 10 parallel paths. So total current will be, this is the voltage per parallel path or voltage rating of the machine, that is 200 volt. Total current will be equal to sum of these all current, that is 10 ampere per parallel path and 10 parallel paths, so it is 100 ampere. So power rating is V into I, that is 200 into 100, and the value is 20 kilowatt. So our answer is,
find out the memory map of the given interfacing logic. Here it's a NAND gate given, therefore it's a negative logic. A 0 expected here to select the chip. This is the memory chip given. So as the lines, address lines of memory chip are 0 to 9, that is 10 address lines. So 2 power 10 is 1 KB, must be the capacity of this particular chip. So let us see what is the decoding logic required for it. So here if you observe, it is connected with VCC. So it's a NOT gate. To make the NAND gate output to become 0, all the input lines should be high. Therefore it is 0. if you require all the lines should be high, it requires 0, 1, 1, 1, it is 0, it is 1 more is also 0. Therefore, here if you observe the decoding logic is 0, if you put into the lines, let me take like this, VCC, that is plus 5 volts. So the starting address is, so remaining is only a range for the memory chip, that is 0, 0, 0. A0 to A9 is the range of the memory chip, starting address, ending address. Decoding logic is 0, 1, 1, 1 and this is 0, 0. And all the remaining lines are taken as 0 for the initial address. If you take the hexadecimal equivalent of this value, this is 7000H, and decoding logic would remain same and the ending address will be considered when all lines are high. That is the maximum value. If you take the equivalent value of the address, that would be 73FF, and hence the option is
in this problem we have to find out the diagonal matrix corresponding to the matrix 2 0 1 0 2 0 1 0 2. Now if you find eigenvalues, then automatically we can get diagonal matrix. The characteristic equation is determinant of a minus lambda equal to 0, determinant of 2 minus lambda 0 1, 0 2 minus lambda 0, 1 0 2 minus lambda equal to 0. 2 minus lambda of 2 minus lambda whole square minus 0 plus 1 of 0 minus 2 minus lambda equal to 0. Now 2 minus lambda whole cube minus 2 minus lambda equal to 0. By taking 2 minus lambda common, you will get 2 minus lambda whole square minus 1 equal to 0. Now you can write lambda equal to 2, here lambda square minus 4 lambda plus 4 minus 1 plus 3 equal to 0. By this lambda equal to 1 comma 3. Therefore lambda equal to 2 1 3. Therefore the diagonal matrix is 2 1 3 or 1 2 3. The diagonal matrix D is 1 2 3. After diagonalization of this matrix, you will get diagonal matrix 1 2. In this problem, the real part of the analytic function is provided. U is equal to y plus e power x cos y. Now we have to find out imaginary part of the analytic function. Now find ux. Ux is e power x cos y. Uy 1 plus e power x into differentiation of cos y minus sin y. Now dv equal to del v by del x into dx plus del v by del y into dy. Vx equal to minus uy, then minus 1 plus e power x sin y dx. Vy equal to ux, therefore e power x cos y dy. Now we got dv in terms of x and y. Now we have to find v value. Now v equal to, take integration on both sides, you will get v equal to minus x plus e power x sin y plus c. E power x sin y dx plus e power x cos y dy, that is minus 1 plus differentiation of e power x sin y, right? By taking integration on both sides, v equal to minus x, integral of differentiation is function plus c. That is the correct. In this question, Norton's equivalent resistance between the terminals A and V is 3 ohm. Then we have to calculate the value of alpha. Okay. So to calculate, since it is having a dependent source, so to calculate Norton's equivalent circuit, let us apply a 1 ampere current source here. And suppose the voltage this terminal is Vx. Then Norton's resistance Rn can be equal to Vx upon Ix, which is equal to Vx upon 1. Now, suppose the voltage at this point is V1. Then applying KCL, we have V1 minus alpha into Ix divided by 1 plus V1 upon 1, and this current 1 ampere entering is equal to 1 ampere. Ix value can be put as 1 ampere, so V1 minus alpha plus V1 is equal to 1. So 2V1 is equal to alpha plus 1, so V1 is equal to alpha plus 1 by 2. It is the value of V1. Now Vx can be written as, this V1 can be written as basically V1 is equal to minus Ix into 1 plus Vx. So we can write it as Vx minus Ix. Putting this value of V1, we have V1 Vx minus Ix is equal to alpha plus 1 by 2. But Ix is equal to 1, so Vx is equal to 1 plus alpha plus 1 by 2. This is equal to 2 plus alpha plus 1 by 2, that is alpha plus 3 by 2. It is the value of Vx. And from here, Norton's equivalent is nothing but equal to Vs. So alpha plus 3 is equal to, by 2 is equal to, given in the question, 3. So alpha value is equal to 6 minus 3, that is 3. Answer for this question.
Open loop transfer function of a system is K upon Ss plus 1, 1 upon Ss plus 1. It is desired that the velocity error constant of the compensated system is to be 10. And if it is required, to be obtained by a compensator whose transfer function is S plus Z by S plus P. Question is to find the value of Z by P. Velocity error constant formula Kv, it is given by limit s tends to 0 S g of s h of s, which for this question is Z by P. It is mentioned that this has to be 10 and the value of Z by P should be 10 for that. Is that
In the next question, Fourier transform of given signal is in the form of A upon B plus omega square, and here we have to calculate the value of ratio A by B. Now, first of all, suppose if signal is e की power minus A modulus of t. For e की power minus A modulus of t, Fourier transform is 2A upon A square plus omega square. Here A should be greater than 0. Now the given signal is in the same form. Here value of A is 2. So for given signal e की power minus 2 modulus of t, Fourier transform will be equal to 4 upon 4 plus omega square. When we will compare the obtained x of omega with given x of omega, then value of A and B, their values are 4. Therefore, the value of ratio A upon B will be equal to 1. So answer for this question.
Problem A, DC shunt motor develops 20 Nm when the armature current is 40 ampere. If it is changed to a cumulative compound motor by adding series field with increase in 20% of the flux. We have added some series turns and flux increased to 20%. We have to compare. So T is proportional to phi into Ia, from T is equal to K phi Ia. So basically we can write it at T2 by T1 is equal to phi 2 Ia2 divided by phi 1 Ia1, or T2 is equal to T1 into phi 2 Ia2 divided by phi 1 Ia1. So from here 20 into 1.2, 51 by 51 into 60 by 40. So this value will be 30.1.2 and the answer is 36 Newton meter. So our answer is 36.
This question is about calculating the intrinsic gain of a BJT, and that intrinsic gain is defined as the multiplication of transconductance of the BJT and dynamic output resistance of the BJT. The product GM into R0 is named as intrinsic gain, and to calculate that, the data provided is early voltage of the BJT 100 volt and temperature mentioned as 27 degree, and at that temperature we can take thermal voltage approximately as 0.026 volt. Now to calculate this A0, we will just apply the formula for transconductance and R0. A0 is equal to Gm multiplied by R0. That Gm is transconductance, it will be collector current divided by thermal voltage. That IC is called operating current or DC collector current of the BJT divided by thermal voltage. That will give you transconductance, and this multiplied by R0. R0 is approximately early voltage divided by the collector current. That IC term will cancel out, it becomes VA divided by VT. You can substitute here VA as 100 volt and VT 0.026 volt. And if you calculate this, it will evaluate to 3846, and that you may convert into kilovolt per volt. It will be like 3.85 approximately kilovolt per volt. So this is the intrinsic gain for the BJT in the given question, 3.85 kilovolt per volt.
Using n number of flip-flops, a binary ripple counter is built. The frequency after each flip-flop is given as F1, F2. So F1 is the frequency after first flip-flop, F2 is the frequency after second flip-flop, and so on. And we are having a relation as Fn by Fn plus 1 by 2 is equal to F6 by F1. So F6 is the frequency after sixth clock pulse, F1 is the frequency after first clock pulse. Similarly, Fn is the frequency of a flip-flop of Fn is the frequency of nth flip-flop output, and Fn plus 1 by 2 flip-flop output frequency. And here we are having a question, what is the mod value of this counter? We need to recognize what is the mod value of this ripple counter. Let's consider clock frequency which is used on this counter is Fc. So the frequency of the first flip-flop, if you look, it is coming to be Fc by 2, and the frequency of F6 flip-flop, if at all you are looking, it is coming to be F6 divided by 2 to the power of 6. Similarly, the frequency of nth flip-flop output is Fc by 2 to the power of n, and the frequency of n plus 1 by 2 flip-flop output is Fc by 2 to the power of n plus 1 by 2. Now if you substitute these values in the given relation, we are looking here Fn as Fc by 2 to the power of n divided by Fc by 2 to the power of n plus 1 by 2 is equal to FC by 2 to the power of 6, that is F6 divided by FC by 2. So from this we are looking effectively as 2 to the power of n plus 1 by 2 divided by 2 to the power of n is equal to 2 by 2 to the power of 6. So it is coming to be 1 upon. So you can look here, it is coming to be now n minus of n plus 1 by 2, so that it is a 2n minus n minus 1 by 2. So effectively it is coming to be n is coming to be n minus 1 by 2. It is coming to be 1 upon 2 to the power of n minus 1 by 2 is equal to 1 upon 2 to the power of 5. So that n minus 1 by 2 is equal to 5. If you evaluate this, it is coming to be 6. So that number of flip-flops, if you evaluate this, it is coming to be 11. So number of flip-flops which are used in the counter are 11. Hence the mod value, based on this, the mod value will be to the power of 11. So 2048, the answer is 2048.